Welcome to Presentation 30. Today we're going to be talking about the BMP files. In particular, we're going to learn all about reading BMP from a FAT-32 formatted HCSD card. This is the 3 of 3 presentation. So as usual, we start by our architecture. So the SDHC is part of our layer 3 architecture, and it uses the UART framework from layer 2, SPI framework, and IO port frameworks. We're also going to use from layer 3, we're going to use the display framework. So the agenda for today, we're going to be talking about reading BMP file from a FAT-32 formatted HCSD. I'm going to give you the background, and I'm going to show how to go about reading those types of files. Next, we're going to go through a sample program, and finally, we go through the summary. So let's get going. Okay, so the idea here is that we're going to have a BMP file stored on a card. Then what we are going to do, we're going to navigate to that location where our BMP file is. We're going to grab the data from the BMP file, and then we're going to display it on a display 240 by 330 of resolution. So how do we go about doing this? So first thing we do is we're going to go to our sector 0, and as usual we read our boot record. Now at this point, all we have to get to our BMP file is the name of the file. But we go to root 0. From there we navigate, we get the master boot record. We navigate to the boot record, and from the boot record we're going to navigate all the way to the root directory, and that's what we've been doing. That's what we learned how to do, I should say, the last presentation. So when we get to our root directory, we're going to look at the file information, and based on our name of our file, we're going to find the file information associated with our file. And from there, we're going to get the starting cluster. So with the information of the starting cluster, we're going to find which the cluster. So the starting, we use our formula to this starting cluster, and we find our sector. Now the BMP file characteristics are as follows. So when you get to the sector containing the BMP file, what you're going to find first is a BMP header. Now that header has all the information you're going to need to get your data, the data associated with the BMP picture. Now to give you I should say that from that file, from this record, which from this sector, you're going to get all the information you need to start displaying pixels on a display. Every 3 words of data is going to define a pixel. So let's keep going here. So let's continue with the background information. So first, we read one or more 512-byte sector containing the header and image data. Then we draw pixels in a display by processing exactly 3 bytes per pixel. Next, the first sector, as I noted, the first sector we read contains the header and image data. Now, sector 2 and on contain only image. So the first sector we read, we're going to have a header and data from the second sector and on, it's only going to be data. And we use three words to define a pixel. If a sector leaves leftover bytes that don't complete a pixel, they get carried over into the next sector. For example, let's see exactly what I mean. So let's assume we read sector 2. Sector 2 has 512 bytes. Now from those 512 bytes, we can, if we divide them by 3, we can get 170 pixels, and we're going to have 2 leftovers. Because don't forget, we need 3 pixels to send to the display. So from the first sector, we're going to have 173 pixels and 2 leftovers. Next, so this is I wanted to show you this loop here. So the first sector, I start with I equal to 0. I'm going to increment the count every 3 bytes, because that's 1 pixel. And I'm going to be able to get, I'm going to have to go up to 508. Now, why do I say 508? So the last pixel that I can, the last 3 pixels that I can read from this particular sector are going to be byte 508, 509, and 510. And the reason is because then 511 and 512 are the ones that are left over, and I have to use those plus 1 extra byte that I'm going to get from the next read. So I go from I equal to 0 to 508. I'm going to get my 170 pixels. Next, let's assume that after reading sector 2, I have 2 leftover bytes. Then I read sector 3. Now, from I use 1 byte to complete the pixels from sector 2. So when I read sector 3, the first thing is I grab 1 byte from sector 2, and I use it to complete the 2 pixels that I needed to complete the pixel. Then I'm going to process the remaining 111. So I'm processing 111 because I already took 1 byte from this particular sector, which is going to give me again 170 full pixels. If I divide 511 by 3, I'm going to get 170 pixels, and I'm going to have 1 leftover byte. So at this time, I'm going to go ahead and let's see what the loop looks to get these 511 bytes. So I'm going to go from I equal to 1. I can start from I equal to 0 because I already used my 0 byte to augment the 2 that were left over from the prior read. So I'm going to go from 1 to 509, 3 at a time. Now, why do I use 509? Because that's the last that I can read, and the reason is because the last 3 bytes that I can read from this second read is going to be 509, 510, and 511. So I'm going to have 1 left over. So I go ahead and read again. So I'm going to read sector 3. So from sector 3, I'm going to use 2 bytes that from that sector to complete the one that I have left over from before. And so the what I have left to process are 510 bytes. Not 510 bytes divided by 3 is going to give me 170 pixels, and with no leftovers. So basically, I can use a loop that starts at 2 because I'm going to use 2 to complete the one that was left over, and I'm going to go to 512, and basically at this point I have none left. So let me say it again. So I read the first sector and I have 2 leftover bytes. So what I do is I read another sector and grab 1 byte from that sector and complete my 3 bytes and then process the rest. When I process the rest, I have 1 left over. So then I do another read and I take the first 2 bytes from the one that I had just read and I process 510, which leaves no leftovers. My first loop is going to be from 0 to 508 because I cannot go any further because the last 2 I don't have 3 to complete. Then I'm going to go from starting at 1 to 509, and finally I'm going to go from 2 to 512. So the idea, what I want to show you is that I read the first sector, have 2 left over, then I read the second sector, I have now 1 left over, and then when at the third time I have none left over. So then I can check if I have any more sectors, and I can go back and do these 3 at a time. So let's continue with the background and information. To show how this whole thing comes together, I'm going to go ahead and use my program. So let's start with the main. So what we do is we initialize our ports. We're going to communicate via SPI, so we initialize our SPI. Then we're going to display a whole bunch of troubleshooting information in our laptop. So we initialize our UART. We have a couple of messages. Then we're going to use we're going to render our picture in an LCD, which is going to be 240 by 320 of resolution. So we need to initialize the LCD. Next, we initialize our SDHC because we're going to get information from the card, from the HCSD card. Next, we have to get the master boot record. We need to get the boot record. Next, we need to get all the way to the root directory. Once we get to the root directory, then we're going to find our file information table, which is going to give us the location of our file, and then we can go get the file and render the picture. Now, how to initialize the SDHC, that was presentation 28, and I'm emphasizing this because it's very important that you see those presentations. So this is going to make it so it would make this explanation much easier. Next, they get the master boot record, get the boot record, and get the directory that was presented in presentation 29. And finally, the read BMP file is what we're going to do today. So let's look at the read BMP file. So the first thing we need to do is we need to find the starting cluster, and we're going to find that in the file information table. So we do all this to get the file information table, and once and from the file information table, we're going to get the starting cluster. Now, we work using sectors, so we have to convert the starting cluster to a sector, and this is how we do that, starting BMP sector. So we've done that in the past. And then we go ahead and we start and read our sector where our BMP file is going to start. So that's what we do here. So we've done all this in the prior presentation. So let's keep moving on. So this is the new stuff related to the BMP in particular. So first thing we do, we get the BMP header. header, and then from that we're going to extract certain information that is going to allow us to get our picture. First, I start with the ID field, and it's just I grab these 2 bytes and I display them on the laptop right here, sector byte 0 and byte 1, and I do that just so we know what ID we're looking at, and it gets reflected on the laptop. The next thing I do, I get the offset where the pixel array can be found. So like we already explained before, in this particular sector, we have 2 things. We have the BMP header, and we also have data. If we want to get to the data, we first have to figure out where it starts. So it's going to start basically right after this header. So we have 4 bytes, and this is where we get the information. So we get the offset BMP. We're going to get that by concatenating bits 10, 11, 12, and 13 from the least significant to the most significant portion of the number. So we get where we are going to get our data for this particular sector. Next, we get the width of the of our picture, and then we're also going to get the height. So we get the width by concatenating the word in our sector 18, 19, 20, and 24 from the least significant to the most significant. Putting that together, that's the width. And then the height we're going to obtain by concatenating the word 22, 23, 24, and 25. So we have the heights here. And finally, what we're going to get from this table is going to be the number of pixels, number of bits per pixel. And that's going to be here. Number of bits per pixels is right here. And that's where it's... So let's continue. So we got to the table, we got the information we needed. Now let's keep moving on. So what we're going to do here is we're going to calculate the total number of sectors, and the total number of sectors is basically the height of the BMP times the width divided by 512. And so that's the information we had from our table. So let's continue. So now what we do from now on, we're going to start getting the words and take 3 at a time so we can render a pixel and render our picture eventually. So now the display we're using, as I noted before, is going to be the 240 by 320 of resolution. So we're going to have 240 columns and 320 rows. So our max X is going to be 239. And then every time we get to 239, of course, we're going to increment our rows. So what we're doing at this point is I'm just going to get the cluster. I'm going to get the data in the cluster, the first cluster, which has 55 words of header. So I start from bit 56 and go to 512, and so I get the so I'm going to get every three bytes I'm going to go around. So I have XY LCD pixels. So I have sector 0, sector I plus 1, and I plus 2, followed by the position. So these three words, X, sector I plus 1, and I plus 2, they define the colors of the pixel, and the X position and the Y position defines the location where the pixel is going to be turned on. Next, after doing that, then I increment the column. So I go to the next position, and after doing that, I check to make sure that I'm not at the end of the row, and if I'm at the end of the row, then I change my X position to 0, and I go to the next row. So in a nutshell, I took care of rendering the first sector. Now the rest of the sectors are going to be all 512. So let's see how I get started. So I have sector to read is going to be the next sector to read, I should say. That's going to be the sector plus 1, because the first I have to increment it by 1 because I already read the first sector with the where my header was. Now the total number of sectors that I have to read is going to be all the sectors minus 1 because I already read the first sector. So what I'm going to do is I'm going to do a loop that starts in 0 and goes to all the total number of sectors. So what do I do in this loop? So first I'm going to read the current sector and increment it. Then, as I noted before, the first sector that I read complete, which is 512 words, I'm going to go between 0 and 508, and I'm going to have 2 words left over. So that's what I do here. I have x, y pixels. I put I plus 1, I plus 2, x and y position, increment my x position, then make sure that I haven't gotten to the end of the row, and if I increment the row. So that's what I'm doing here, and I have 2 words left over. One is so I need to save them and then do a read and complete the pixel with the new read. So what I have here is buffer 0. I put the 510 parameter of the sector, and then here I put the in input buffer 1 I put sector 11. So after doing this, I read the sector and then increment the sector number. And before I do anything, what I have to do is I have to place the pixel that I just that I have to complete 3 pixels, and I have to complete the 3 words that is going to form a pixel and then render that in the display. So to put on display, I have the input 0 and input buffer 1. Those are the 2 left over, and then I use sector 0 from the new read. And then I have my X and Y position, then I check my position. So now I took care of putting that particular pixel. Now I have to take care of the rest of the pixels. So I'm going to do a loop between I equal to 1 because I already used my sector 0 word. So I'm going to go from 1, and then from 1, and I'm going to go to 509 as I've priorly explained, and I'll go 3 at a time. Now when I'm done with this loop, I'm going to have one word left. So I have to save it and then read the array again so I can complete this particular pixel. So I put the input buffer 0, and I put there my word that I have left, which is the sector 511. Okay, next what I do is I read the sector, then I increment it, and then first order of business is placing the pixel. So I use for this 1 pixel the input buffer 0, which is the leftover, and then I get sector 0 and sector 1 from the current read, and then I get my X and Y position. After rendering the pixel, then I check to make sure that that I'm not at the end of the row. If I am, then I take my position to 0, increment my row. Now I'm going to loop with what's left over. I start from I equal to 2 because I already used 0 and 1 and gone to 512. When I do this loop, I'm just going to I'm going to use all the there's going to be no leftovers. So after doing this, then I go back here, and I'm going to loop until I've done that for all the sectors that I need to. Now, once I'm completed there, that should render the whole picture on the LCD. So let's continue with our presentation. Okay, so now what we're going to do is go ahead and go through a sample program where we put everything together. So this is the schematics of how we are going to wire our system. So basically we have as we had before, so we have the LCD and this the card adapter. They are going to be they're going to share the clock and the MOSI, and so basically they share all the elements of the SPI except for the chip select. They have separate chip selects. So the ATMEGA decides where it's going to talk to the LCD or to the adapter, and so what we'll do to read from the adapter using the PB2 as a chip select, and then we deselect it, and then we'll select the chip select for the LCD display. And also for troubleshooting, we're going to send key information to the laptop so it can be displayed. So let's see what we do for this program. So first we have to initialize the SD card adapter, or we used to say the HCSD. We need to initialize that. Next, we need to read the master boot record, which is this record here, which is going to give us the information to go to that we need to head to the boot record. So next we're going to read the boot record, and from the boot record we're going to get enough information so we can navigate to the root directory. So next we calculate the location of the root directory from what from the data we got from the boot record. Then with that information we're going to look at our file information tables, and we're going to find our BMP image. Then with that information we find our cluster, and that gives us the information to get our sector, and we're going to read it gets us to where we have our BMP file, where we're going to read and extract the relevant information needed for displaying the image. So then we're going to display a picture on our LCD, and we're also going to use the serial interface to display relevant information in the laptop. So if something goes wrong, we can go back and see what happened. So let's look at the whole program. Okay, so the objective, or what I'm going to show now, is just to show you the whole program put together. Now I've included all the code for the associated with the HCSD and also with the BMP. The only thing I did not include in this code was the items associated with the LCD, because it just made it too long. So anyhow, let's look at what we have here. So we have the routines that are going to handle the SPI. So we have SPI master, SPI transceiver. Then these routines are the ones that are going to handle the HCSD. So we have command 0, command 8, command 16, command 17. Continuing with command 41, command 55, 58, 59. So that's all the commands we need. And then here we have our routine to initialize our SDHC based on those commands. Next, we start reading. We know how to read a sector, and then after this we start reading sectors and getting information from those sectors. So we have to get the master boot record, get the boot record. Then we have get the root directory. After we get at the point where we get our root directory, now we can start looking and reading our file. So we have read the text file, which is what we did last time, and then after that we have to read our BMP file. So they're fairly similar till we get to the actual file. So this is the information I I already showed you how to get to the BMP, how to render the picture. And finally, we get here to the main. And in the main, we're going to initialize whatever needs to be initialized. Then we get the master boot record, get the boot record, get the root directory. Based on that information, we get our read BMP file. So let's look at the output. So we have our hello world. So we're going to have the starting boot record, sector per cluster. We have a number of FAT tables, root directory. So that gets us to the root directory. And then from this point on, we're actually looking for our BMP picture so we can render it. So we have the start file, the name of the file that we rendered, which was flowers SL, which I called it. Starting cluster is 8. Then starting our picture in our first cluster was at the 16,764 word. Then we have our ID. So this is stuff that I've already explained and kind of comes together here. Offset the data. We have 54. The size of our header was 54, so we started 55. Then we have the width of our picture and the height, which is 240 by 320, which is actually the size of our display. Then total bits per pixel, that would be 3 words, 24 bits. And total number sector, we had 150, so we read 150 sector. And this is our picture. I think it looks pretty nice and basic. What I did is with my phone, I took a picture and then I went to paint and reduce the size of the pixels from to 240 to 320, so it fitted on this particular display. So I think you get a good idea of the quality, and of course you can investigate this a little bit longer and use more bits to define colors or better display, and you can certainly render very nice pictures. So with this, let's continue with our presentation. Okay, so we looked at the output of our program. We looked at a nice picture that we render and the background information. So what comes next is the summary. So basically today we read the master boot record, which we already knew how to do. We navigated to the boot record. We read the root directory. We found the file information tables, and we found our BMP. Read the file information table. Then we access the BMP header and display the contents of our BMP file. So basically, I think today we started from with a file name, with a BMP, and we were able to navigate all the way to get our picture and render our picture. Anyhow, I thank you very much for spending this time with me, and I hope I see you the next time. Thank you.